Hello everyone, this is Team Alpha Century and our project is Biomonitoring Intelligent System, assistance system for high professionals. As we know that there are many critical professions like astronaut and brain surgeons or surgeons who need to deal with the critical decision making. They need to make decisions spontaneously. They need to resolve some kind of issues in less amount of time so that the success rate of any mission can be increased. So in such scenario, we have come up with an innovative idea which will be a assisting system where we are trying to predict what kind of questionnaires are generated in the mind of the user and trying to answer them without user being asking the questions. Now, as we know that in the professions like surgeons or astronaut, they need to take any kind of decision. They need to resolve some kind of issue without any time delays. So in such scenario, they can't be waiting around to tell some kind of question to LLM model and then LLM model will answer them. So in such kind of scenarios, our system will try to analyze their mind, try to analyze their activity and predict the questionnaires which might have generated in their minds and answer them as quick as possible so that any kind of issue can be resolved in real time in less amount of delays. And our system mainly focuses on what we can say increasing the success rate of any mission or any operation so that less harmful activity can happen. Now our project is not only focused on the high professions like astronaut and surgeons. It can be also implementable for students for knowing whether they are concentrating, whether they are getting the concepts they are learning about. We can have a comparative analysis between different kinds of students so that we can know that which student is getting more what we can say more information about any kind of concept so that we can rank them upon their brain states and all the things. Similarly, we can use this for drivers to know whether they are concentrating, whether they are what we can say driving focusedly or not, so that the road accident can be decreased and the road safety can be increased. Now let's see our demo. It is just a prototype. We have created a prototype which will explain how our system works. So for now it is very basic. We will explain you with an demo. Thank you. So now let's first talk about the component we are using. The first one is the EEG electrodes. We have placed three channels EEG in our project. This one is the EEG at FP2 position. We are gathering the data from FP2, which will be like whether the person is concentrate or not and relax or not. Now this EEG are connected with the bioamp cables. Now this bioamp cable is connected with the bioamp EXG pill, which is amplifier which will amplify the signals of EEG. Now these wires are connected with the Arduino Uno. With the help of jumping wires. Now this Arduino Uno will convert the analog data into digital data and will be sent into our system in real time, and we will process this data. Now similarly, we are using the camera. We needed a high resolution camera, so that's why we are using the camera of our smartphone, which will be used for eye gazing purpose. Eye gazing is nothing but a system which will try to predict a predictive model, which will predict where the user is exactly looking at on the screen on the basis of the eye movements as well as the head movement. Thank you. Now let's begin with our demo. Now we are running our script. Now first, all the libraries that we have used in this project will be called like TensorFlow and MediaPipe, so it will take some time. The first of all, our EEG model will be the eye gazing model will be running in front of you. It will show a window in front of you. Now this is our face mesh, where we are forming a different kind of relationship with the landmarks. We have used MediaPipe for that. We have formed the relationship between different kinds of landmarks in order to get the pupil movement as well as the head movement to know where and we have mapped this with the screen coordinate in order to get where the user is exactly looking at. Now for the demo purpose, I am looking at this screen as well as over here. Now simultaneously it is gathering the data related to our EEG, whether I am concentrating or whether I am relaxed, and along with that it is also gathering the voice analysis module. Now as I am talking with you, it will be gathering many different kinds of keyword and trying to analyze my emotion as well as all the things, and it will generate the questionnaires that may have generated in my mind. So for the demo purpose, as I am talking to you, it will generate random question, but you will get an idea how it is working. So I am closing the window. Now it will analyze all the things. Now as you can see that I was looking over here and over here. So from this image you can get that I was looking at what positions. Now once I close this window, it will give me a cropped image which will show that at what position I was exactly looking at. Now it will process all the data collected from all the three models, from EEG, from eye gazing, as well as the audio analysis part. It will give the result. Now as you can see that it is showing the concentration. This concentration belongs to denoting the emotion or the brain state I was having during the conversation, as I was focusing on explaining you. So that's why it is showing the concentration. The emotion is neutral. The neutral emotion is predicted with the help of the voice analysis part. So as I was talking with you, it has predicted some kind of emotion from the words, and the result is the neutral. Now all the three data, the emotion predicted from the voice analysis part, the brain state predicted from the EEG part, that is concentration, as well as the image captured by the eye gazing module, and the environmental data. The here environmental data is nothing but the screenshot of the image, what we can say, the image that we have kept as a background. So this is the environmental data which we have passed. This image, just wait a second. This one is the eye gazing image which showing that where I was concentrating, as well as all the three data are passed on to the GNAI model. Now what GNAI model will do, it will generate the questionnaires on the basis of this data, and it will associate these questionnaires with the probability score and try to so that a model can know that what questionnaires may have arisen in the mind of the user. Now as you can see over here, the 4 questionnaires are generated. The first question is, are you focusing on spaceship control? Now as you can see that this image is related to, just wait a second.
One, are you focused on the spaceship controls? Probably.
So as you can see that the image that we have faded as an environment was this image, and the cropped image was the focus of interest image was this. So it is obviously showing that it is the image of a spaceship. That's why it has taken the reference as a spaceship, and what we can say, yeah, as I was concentrating, that's why it is telling that are you focused on the spaceship control. Now in the critical scenarios where we can predict more brain state like decision making, or we can have a more kind of keywords in my speech, like whether I want to land on a surface or something important I am talking about. At that time it will extract the keywords and it will feed it to the system. In those kind of scenario, it will generate a better kind of question. We have experimented this project for different scenarios, and it has worked pretty well. So I think that that's all from our side. Thank you for listening.